This Dan Bullard, retired electronics engineer, sitting on the front deck of my houseboat again. It's chilly, but I got my heater going, and the fog is back there. It's really cool, huh? Really cool, eh? I'm not Canadian. I want to talk about memory leaks, and you might or might not be familiar with it. You know, I don't know just hardware. I know software too, and it turns out I got recruited to solve memory leaks all over the world. It's friggin' incredible. In one case, there was a customer in Germany, in Freiberg, Germany, ITT, and they had a problem, and they would be testing this device that they had on I think it was a Credence VistaVision or something like that. And because it was mixed signal, they picked me because they was pretty sure it was a mixed signal problem, but it wasn't. It was stupid. We got the notification that we were going to be going. I was going to be going along with another guy named Homer Time, aka Doug Lynch, and he was going to be going to Germany with me, and he got to drive the rental car. So we got to go into Munich and fly down to hey Alan, we got to fly down to Munich or down to Freiberg together. He got to drive on the Autobahn. It was great. He got to do all the driving. It was really nice. I didn't have to do any driving for a long time. So we didn't know what the problem was, but a whole bunch of us, me and Homer and another guy who sounded just like Siegfried on Get Smart, and some other guys went there to look at this problem. And we worked on it for weeks. And we proved that it wasn't a hardware problem, so Doug Lynch got to go home. We stayed on this in this hotel overlooking Freiberg, and it was great. It was a great hotel, and they had a great Pilsner beer there, fantastic. So we worked on it. The problem is in Germany you can only work 8 hours a day, 40 hours a week, and so I was there for the duration until I could get this problem solved, even though I could only work 40 hours a week. It was crazy. But we worked on it. We had this manager from ITT. His name was Hussein or Mohammed or something. And he came up behind us one time, and I was sitting there with Stefan, the guy who sounded like the guy from Get Smart, and he said, you know, if you guys were from Teradyne, you would have this problem solved in no time. And, you know, me and Stefan just looked at each other, and he walked away, and Stefan says, is this Mr. Samaha? That was his name, Mr. Samaha. This Mr. Samaha, I really hate this guy. It was friggin' great. But it turned out we were working on it. We were sitting there, basically sitting in chairs like this. That's what I did with my life. Sitting in chairs, working on stuff. But we were sitting there, and I set up a loop where I could keep an eye on the memory usage. And so while the test program was running, I would keep an eye on the memory usage. And like I said, with this program, we would get through about 3 wafers, and then it would crash out. It would basically, the CPU would die and crash, and we couldn't figure out what it was. So, but we noticed that we were watching the memory usage. We noticed that the memory usage would go up whenever we got a lot of functional fails on the part, which, you know, it had like a yield of like 90%, so it didn't happen all that often. But if we got some functional failures, the memory usage would go up, and it wouldn't go back down. And that was kind of the key, right? So the memory usage is going up, and then it's not going down, and it would do that every so often, every time there was a lot of functional fails. So that means, you know, the truth table is failing. So I figured out what it was, and so but I couldn't fix it because I didn't have access to the system software. So I got on my hold of my buddy, believe it or not, Daver. I mentioned him many times, and he's real. He's not imaginary. It's not like I'm real and he's imaginary. He's real, and he'll make an appearance at some point. But Daver, he was the only software engineer who was stupid enough to admit that he had a passport. And so I came home after 3 weeks. He flew back there and he looked at it and found out it was a memory leak in the functional software, because what they did was anytime there was a functional fail, it would accumulate all the fails into a memory and then store it, but not delete it at the end of the device. And it was just a stupid thing that they did in the software. So we found out that they had recently updated the software. Nobody put two and two together. But they had updated the software, and then suddenly they got this problem where the program was crashing after 3 or 4 wafers. So that was a memory leak. That was my introduction to memory leaks. Then I was working at, I won't give you the company name, but its nickname was Inhell. Although actually it was a pretty good place to work. But I had this gal come to my office, and she said, "I want you to take a look at this. Your tester is fucking up our probe cards." And her complaint was that their $20,000 probe cards were getting smoked by this failure. And so they would get through 2 or 3 wafers. Sound familiar? They get through 2 or 3 wafers, and then the thing would latch up. And so the operators would say, "Oh, well, the prober's stuck Z up." So they would hit the Z down button and whammo, $20,000 down the tube. So it wasn't my fault, but they made it sound like it was my fault. So I went and looked at it with the gal who wrote the program, and we sat there on the test floor, me wearing my Birkenstocks, because they required you had to be in a full gown and all that stuff, but they allowed you to wear Birkenstocks, which was wild. So anyway, we worked on this, and I figured out what it was. And it was just like the other one at ITT. It was a memory leak. What was happening was, this gal had written the code, and it was for an L2 cache for the Pentium 3, I think, or Pentium 2, I can't remember. Oh, I'm sort of gave away the name of the company. Anyway, so it was an L2 cache, and what she was doing was, it was a standard thing, when you have a memory failure, you store the memory failure, and you build a table of all the memory failures, and then you can work out whether you need to fix a row or a column. Now, in memories, they have redundant rows and columns built into the memory. And so what you do is you try to figure out, based on the failures with the bad cells, how to optimize which row or which column is better, and which one would be better if you got rid of it. And so she was doing that. She was storing the failures in this memory. And she was doing that using a linked list. A linked list is really very cool, unless you're stupid. And she was stupid. So what was happening was, she was building up this linked list of all these memory failures, and then she would fix them by substituting in the redundant rows or columns, validating that everything was working, and then, hey, the L2 cache is good, close it up, close the program, and walk away. The problem is she didn't delete the linked list. She deleted the pointer to the linked list, but that left the memory allocated. And so within 2 or 3 or 4 wafers, the thing ran out of memory. The poor CPU in the tester ran out of memory, and it would lock up. And it would lock up in the Z up state. And that means the probes are down on the device, right, with several amps flowing. So the only way to get out of it is to do a Z down on the prober and whack, blow the probe card to bits. So it was their fault. It was their fault. And I never heard squat from them. They never apologized. It was not my fault, and even though they yelled at me that it was my fault, it was my fault, it was their fault. It was a linked list problem because she didn't know how to delete the objects inside of a linked list. With a linked list, what you have to do is you have to go through the list, starting at the bottom, and work your way up and delete everything that you used. Otherwise, the memory allocation software, or firmware, wherever it is, thinks that you're allocating the memory forever. So you ran the CPU out of memory. So that was my second example. One more. I was working at Maxim, and I was using a tool that somebody had written that data logged the whatever data to the screen, and I was, for some reason, I was looking at the memory usage. Oh, because I was running this thing, I was really bad. I'm so lazy. Because this is a production test program, I would run the program over and over and over and over and over again. Run it continuously. And I would like go home, because I lived in an apartment near there. This is while I was waiting for this houseboat to be built. So I'd run it for hours and then go back and check on it, getting paid all the way. But, you know, it's not like they got any free time because I was putting in like 12 hours a day. So it's not like I was doing 8 hours a day and wasting 6 of them. So I noticed that it was using up the memory. So I went and looked for it, and unlike the other things that I had used, I just used memory tools in this case. In the other ones, I used one called Purify, which I came to name as Putrefy. But Purify is a really great software tool. It shows you exactly where the memory leak is. I don't know if they're still making it, but they still owe me a coffee cup. Because I gave them a good review, and they had a thing, if you give us a good review, we'll give you a coffee cup, and they never did. But in this case, I found out what it was the data log data, the text that went into the data log data got stored into a memory allocation through an allocate, and then it didn't get freed, it didn't get deallocated. And so I had to go into the software and tweak the software to deallocate it and get rid of the memory leak and fix the problem. And it never really affected anybody, but, you know, you don't know how long a test program is going to run. It could run for hours, it could run for days, it could run for weeks. And if this program ran for weeks, it would run the CPU out of memory. So it's a good thing I found it, because nobody else knew what to look for memory leaks. So I became an expert at memory leaks. So I don't know just hardware, I know software too. And Purify was one of my great tools. I got Intel in Santa Clara to buy, I think, 4 copies of Purify. They owe me that coffee cup. So if you have a Purify coffee cup, let me know and you can mail it to me. Anyway, memory leaks are bad, and there's a lot of tools. Look it up. There's a lot of tools for fixing memory leaks, but if you do a linked list, don't assume that just deleting the top of the stack is going to throw away the data. It's going to lose the pointer, and then you can't get to it, and that memory is allocated forever until you reboot. So memory leaks are very, very, very dangerous. So like I said, I worked on hardware, I worked on software, I wrote software, I've written software that is being used in the system software of Credence and everybody else. So I'm pretty well rounded. So don't ignore me, okay? Anyway, this is Dan Bullard from the river.